Okay, so let's just one by one go through these integral properties. The first one, if you have integration of from a to b on a constant function, that's always gonna just equal to c times b minus a. So any constant function is a what? Graphically, it's a horizontal line, right? Here's c. And we're integrating from a to b. So we're looking for this area here. The area is a rectangle. That's why it's going to be just b minus a times by c. Now the property 2 and property 3, it just follows from the fact that, if you remember, integration is another way of writing the sigma notation with limits. So remember, sigma notation had this property of, if these were sigma instead, if this notation was sigma instead, we can separate the sigma, do distribution on it. That's why property 2 as well as 3 works, because they're the exact same property as sigma notation, as well as 4, subtraction. So 2, 3, 4, if you understand that integral notation is equivalent to a limit combined with sigma, then they're the same property. They should be the same. Property 5 is a little bit more interesting. Okay, property 5 is saying this. So if you have a function, so I'm gonna make it look obvious. Okay. Here we have a and we have b. And there's a c. Okay. Now if c was in the middle of AB like this, it's pretty obvious that the area from A to B, the whole area, is equivalent to the area from A to C plus the area from C to B, right? So this clearly is true. But the problem is, it didn't say the C was in the middle. Okay, so does it work if it was like this? So let's consider if here's A and here's B. Let's consider if it was C was to the left. Okay, so area from A to B is this one, okay? This one here. Now area from A to C is this down here. So I'm gonna label that A, big A, okay? Now, if you integrate from A to C, is the area going to be positive or negative? So, I'm sure all of you want to say positive because visually it's above the x-axis, right? But it's negative. Why? It's because of delta x. Delta x is always the finishing interval, so the ending interval, which is c in this case, with the starting interval divided by n, right? But which one's bigger, A or C? A is bigger, right? So what is the quantity of this going to be? Is it going to be positive or negative? Negative, right? So we're going to be multiplying every single height by delta x, but delta x is negative. So if you integrate from backwards like this, A to C, it's going to generate a negative area of A. Okay, now now the second part is integrate from C, right? C to B, so it's from here to here. So this whole area now, that's going to be positive, right? So let me say that's area A and this is area B. Okay, so here look. Integration from A to C plus integration from C to B, if C was to the left of A, is the following: minus A plus A plus B. Does that make sense? Minus A, C to B is A plus B. That gives you B still. That still gives you the integration from A to B. So the last case scenario is if we have a function a, b, and c was to the right of b. Okay, again, let's do the same thing. Let's call this a and b. So integration from a to c is a plus b. integration from C to B gives you minus B. So adding these two things up, it gives you exactly A. And A is exactly the area integration from A to B. So it's still true. So it doesn't matter where C is, it's always true. Okay. So the last property, the property 6, I just talked about it actually. Remember I said, we just all agree that if you integrate from B to A, it's going to be negative of A to B, right? So if you want them to equal to each other, you got to multiply this one by negative 1. Right? So it's discussion of what happens if you integrate backwards, right? B to A, this way. Same area, but negative area, because of the delta x being negative. Okay, so you understand all the integral properties from 1 to 6.